Hello, I'm going to be going over Champion Select, the 466 and 566 project. So the point of this project is to help players choose a character in the game League of Legends quickly because they have a time limit and there's a lot of variables and probabilities that they need to be able to account for before they choose a champion. So here's a quick example of the scenario that we're going to be dealing with and that we created this program to help with. So here you see on the left is our ally team, and this is me right here. And on the right is the enemy team, and we do not see what they're choosing yet. So right now we're going to be banning champions. I'll try to make this quick. So we're all selecting which characters we do not want anyone in the game to play. So that takes those out of our domain of choices, and also everyone's domain of choices. So once the champions are banned, we can then go on to choosing the ones we want. So my team here is all showing their cards pretty much and what champions they want to choose. And the enemy team is currently choosing, so let's skip ahead. So right now the enemy team chose this champion. My teammate just chose this champion, and this guy's thinking of what he's going to do. So skip ahead, and he now chose that. So now the enemy team gets to choose two champions, and we'll skip ahead. So now that the enemy team has chosen two champions, it's my turn to choose a champion. So the information I have is that these three people will be playing this champion on my team, and these three people will be playing these champions on the enemy team, and these champions up here cannot be played. So now I have to make a decision in 20 seconds based on all the variables of what I want to do or what I should do for the best outcome. So that's pretty much the program I need to be able to choose right now what's going on. So in order to solve this problem, I needed to first get all the information I need, all the data on these champions and all the probabilities on how well they play against other champions and etc. So I needed to create a huge database, but creating it by hand would not be practical. So instead, I created the program that will go to websites and grab the data. So here I have simply start out with an initial database file, and all it has is a list of all the names of the champions. Quite a bit of names, and with each name having at least 30 values to it, it's too much to do by hand. So we'll start up the program I created. And here I can put in values for the database number, the game patch, and the GUI patch. These GUI patch and database number are my numbers, and I use these to talk with the server for automatic updates, which I'll go into later. So we can hit the Create Database button, and it's going to start going through all of these various websites and grab the data we need from each site and apply it to the database under this champion's name, for example. So these are an example of 3 of the sites we go through, and we grab all of these data points. We do not use all the data points because there's too many, but it's always nice to have in case in the future you want to incorporate other variables into your program. So here's a list of what the code looks like I have to sort through to get the values. So now that I created the database, let's go through it. And this is pretty much what the database looks like. So you can see we have a name with a huge amount of variables, and here's champion names that the champion is good against with a percentage of how many games they've won against that champion. So we have a lot of probabilities and statistics for us to play with. So now that we have that, I can upload that database to the server you see down here, bottom right, as well as the updated GUI program. So when you click champion select updater, it's going to go through the database and make sure that your version of the program is the same version that the database says it should be. If not, it's going to automatically download. And in this case, it's downloading because I didn't even have the executable file here because it's a first-time launch. So when it's done downloading, it's then going to launch the champion select. It's going to download the database automatically every time and tell you that it's now updated to 2.1. And this is our champion select GUI. As you can see here, we have ally bands, so we can type in the characters that are banned here, type in the characters that we choose, that our team chooses here, and notice there's only 4 slots because you are the 5th choice and you should not be choosing before you ask the program what to choose. Enemy team, however, can have 5 slots because they can, everyone on the enemy team can choose. The enemy bands are also right here, so you can type all that in, and then the position, because every time you start a game, you know what position you're going to be playing, so the program needs to know what position you're planning on playing so it can give you the best recommendation possible. So as you can see here, I'm filling out these names. I'm just grabbing random names from my database to simulate what an actual team would be choosing. So we're assuming that I am the 4th chooser on my team, so that's why there's 3 already chosen. And the enemy team has already chosen 4 people out of 5. The program doesn't need to have all these values filled because in practice, you do not always have all these values filled. So we're going to put in the position that I want to be playing, which is ADC, stands for attack damage carry, and we will hit the recommend key with these values for counterweights and match weights, which I'll go into later. So now that we hit the recommendation key, we have our recommendations. So first, let's talk about these side values. Every champion is ideal in a certain role based off of the probabilities from the data table, and the program will go through whatever champions that we gave it, and it will find the most probable roles that those champions will be playing, because we honestly do not know what roles, the player does not know what roles these champions might be playing, but the program is very good at using these probabilities to come up with these roles, and they have a very high accuracy. As you can see, it honestly is not very easy, but let's say, for example, Jack. Yeah, we can do Jax. It says Jax would be jungle and Jace would be top. So if we go to here, we can see that Jax is known for 50% jungle and 49% top. But it does not just grab the highest percentage, because for another example, Jace is known more for top than Jax is. So it will go through every single iteration using forward checking to maximize the values. So it knows that, you know what, it will get more out of it putting Jace top and Jax jungle instead of Jax top. Even if top was 55% here and jungle was 45%, it would still make that decision. And it will do that for enemy team and ally team, and that allows me to then give a better recommendation because I know what role a champion's going to be playing. So it says that Jinx, the champion Jinx, it would be the best bet, and then it also gives a list from best to worst, and we will go through exactly how that happens in a little bit, because each value is weighted, and we can actually see what the weights end up turning out to. So here we go. We're going to do a demonstration of the image I guess it's image processing. We're going to want to because there is a lot of values to put in by hand, we're going to want to have the program take a screenshot of the client where you're choosing, use facial recognition to figure out who is on your team and who is on the enemy's team, so you do not have to put these values in by hand. And remember, the reason that we have to do this is because the client does not allow for you to use API to make calls to find this out. They want to prevent this. So here we see I clicked on the screen button up here, and what that does is it screenshots the client, and now it will list out what each person is. So you see here it grabbed everybody. This is Nasus, Karthus, Kog'Maw, and Jax. And then Shyvana, Rise, etc. And that is really good because we are on a time limit and people do not have time to be putting in values. So you can see it tells me to choose Draven. That's the most recommended choice, and therefore I can choose Draven right here. And now my team is the most optimal it can be. So here's another example of a different team comp with the screen button. I find it really cool, so this is probably my favorite part of the program. Here we click again, and it'll grab these values on the left-hand side. So that's how it knows which champions, which pictures are on your team and which pictures are the enemy team. Is it goes and it will divide the screen by half, and it'll search this half, and when it finds the picture here, it will know that it needs to put it on your ally team, and when it finds a picture on the right-hand side, it will know to put it on the enemy team. So we'll see it is really accurate. Here we go. So it tells me to choose Camille as the first pick, so I chose Camille, but I can also choose any of these other ones, starting from the top as the best second choice, etc. So here's an example of the screen button grabbing the client's screenshot. And the way I were to go about this, because Java does not support grabbing an application screenshot, is to use a C# program called lol screen grabber in the same folder as the champion select. And what the champion select will do is call lol screen grabber and execute it when you click that button, which will then take a screenshot of the client and post that screenshot to the same folder, where the champion select can then reach it again for analysis. So as you see here, it just created this game screen of my screen. I'll open it up, and it's the same screen. And here we'll do it again on a different window. I can hit the screen button, and then that file game screen is replaced with a new screen. So it's just an example of how we went about doing that in Java, which I understand won't work on a Macintosh, but that's about the only way I could figure out how to do that. So here I'm going to put in some values. Okay, I'm back. Here I'm gonna put in some values into the GUI, simulation on what a real team would be. And what I'm gonna do is show the console debug output that will go over more detail of how the algorithm works for doing the recommendations. So I'm gonna hit the recommend key, and we have our result. And then we have the debug menu. So up top we have it telling us what we already know here, the positions that it believes the champions are going to be in. Then under we have what the ideal champion would be. So the way this works is it uses quite a bit of probability and recommendation algorithms, creating vectors, and then altering those vector values. So the values we have here in this box, what it does is it takes the average values for all of a champion in the role that we know you're going to play, and it creates the most average champion in that role. Then what it does is we go through a bunch of logic, and I use error functions to pretty much take, for example, if the enemy team has a high average magic damage compared to, the overall average magic damage of the game, it will know that it does not need the next enemy champion to choose high magic damage. It needs the enemy champions to choose something else because we want a balanced team. So it will take a champion vector, and it will start tweaking its values where if you get a negative number, it means that it wants a lower value in that spot. So here you can see it didn't change the magic damage, physical damage, and true damage, but it did change the actual magic damage, and the actual magic damage is a different calculated value. But you can see it says it wants more of actual magic damage, it wants less of physical, and it wants more of actual true, etc. And these values then can get multiplied by added to the ideal champion. And what that does is it creates pretty much a 12D vector of what the best choice would be when it comes to the logic I just explained. So we have this here, and then going down, we have these values here. So the dot value is going to be the normalized dot product of the ideal champion vector with the actual champion here. So as we can see, Poppy has a 0.8, which is the lowest of all the choices we have. So that means that this champion is the farthest away from this logic that I just described. The second value here that says rec, what that is it takes all of the probabilities that a champion will be better than another champion based on that database I just created, and it will then figure out which champions will be overall have the best chance of winning based off of just the probabilities. So we're not going off of, the team needs this to balance it, so get this. No, we don't care. We're just talking about, all right, we know that the team has these 3 champions, so we want to pick the champions that we already know statistically go well against that. And that is what this REC value is. And as you can see, the highest the value goes to here would be, I think, 6.3, which means that probably there were 2 enemy champions that were really weak against this one champion. Therefore, we can get this bumped up to here. So then I will take the dot and the rec, and I can then weigh the dot or weigh the rec when I add them together, and that will give me my result. And those weights we saw were here. So I could decide that I don't care about what champions are statistically good against other champions. I could set this value to 0. I only care about creating a champion that will balance the team as much as possible using the recommender vectors, or the other way around. So that's where those values come in. here, what we can do once we use these two numbers together is we'll get a final number. And you can see that the highest number will be the most probable champion of winning the game for you. So it would be the best recommendation. And each character is weighted. And it goes all the way from 2.1 down to 1.8, where Tarek, this champion down here, would be the worst suited, while Karma would be the best suited. So, thank you.